All right, problem 2-36. Find the vertex of each of the following parabolas by averaging the x-intercepts. Then write each equation in graphing form. All right, this is a little throwback to Algebra 1. This was emphasized in Algebra 1 if you took Algebra 1 here at our school. So we have our first problem here. We have a function. This is a quadratic function, and it's written in factored form. A key to successfully working through these problems or making it easier on yourself is to notice what form they're in first. So in this case, since we're in factored form, which looks like this, y equals a times x plus b times the quantity of x plus c. And remember here that we can take it, and when we set it equal to 0, we can end up with figuring out what our x-intercepts are going to be. By using the zero product property, we could set each factor equal to 0. X plus b equals 0, and x plus c would equal 0. A would equal 0 if it was important, but it's just a stretch factor in this case. We subtract our b, and we get x equals negative b. We subtract our c, and we get x equals negative c, so that our points then would be negative b comma 0 and negative c comma 0. That's the coordinates of our x-intercepts. So what we're going to do here is we're going to do the same exact thing with problem A. Let's put in 0 for y, because that's what our y coordinate would be on the x-axis. And we've got x minus 3 times the quantity of x minus 11. Let's use the zero product property to get our x-intercepts. So x minus 3 is going to equal 0, and x minus 11 is going to equal 0. We're going to add 3 to each side. We get x equals 3, add our 11, we get x equals 11. That means that our x-intercepts there are going to be the point 30 and the point 11, 0. Now we're not finished here. We still need to find the vertex, okay? And then we need to write in graphing or vertex form. But I just want to show you, in case you're unsure what you're doing, let's graph this real quick. We have the quantity of x minus 3 times the quantity of x minus 11. I'm going to graph it here, and you can see it probably won't all fit on here. So let's just adjust our window. Let's increase our x max to 15. That way it'll show up on here for us. And you'll see here what we have is the point 30 and the point 11, 0. Now we've got that axis of symmetry that's going to run right down through the middle of our parabola, which would extend down to our vertex down here. So if we want to figure out what the x coordinate of our vertex is, it's going to run exactly between all of the points here. So if we take our x-intercepts, 3 and 11, we can get our x coordinate of the vertex by taking it and averaging them. So we're going to do 3 plus 11 divided by 2. 3 plus 11 is 14. 14 divided by 2 is going to give us 7, which means that h is going to equal 7 in this case. And if h is 7, we still need to figure out what our k is going to be. And remember, k is the y coordinate of the vertex. And right now what I'm referring to here is our vertex form or our graphing form, in which case we would have y is equal to a times the quantity of x minus h squared plus k. This is our graphing or vertex form, because we have our vertex is going to be the point hk. So as we do this, we still need to figure out what that's going to be. We know the input, so we just need to figure out the output. So we're going to take it now, and we're going to plug our 7. So we know our vertex is the point 7, comma, something. So let's plug it in. Let's do the function f of 7 should equal 7 minus 3 times 7 minus 11. 7 minus 3 is 4. 7 minus 11 is negative 4. So we multiply that, we should get that f of 7 should equal negative 16, which means that is what our k value should be, negative 16. So if we look at that graphing view here one more time, we'll look down here. We can't see the bottom, so we could take our window and decrease our y min. Let's make it negative 20. When you see your graph, it looks like that's about right. We can double check a couple different ways. Let's just look at the table since it'll be the fastest. And if we have our point, we're looking to look at 7. You see we're at 7, negative 16, and that is the lowest point there. So to take it now and put it into our graphing or vertex form, we're going to end up with y is equal to, now our a value, a here is just 1, so that means that a is going to be 1 here, so we don't have to worry about putting that in. We're going to have x minus 7, that quantity is squared, minus 16. So there is our graphing form of this parabola, and this is the vertex. So let's look at the second one here. I'm not going to go as in depth because I just did all that there, but remember we need to set it equal to 0. So we have x plus 2 equals 0 and x minus 6 equals 0. So we subtract our 2, we get x equals negative 2 and x equals 6, which means our parabola is going to cross the x-axis at negative 2 and 6. Now to get our x coordinate, or what our h is going to be, we're going to take it, I'm going to just call it h because I'm out of space there, but this is like what I did right here. We're going to average them. Negative 2 plus 6 divided by 2. Well, negative 2 plus 6 is 4. 4 divided by 2 is going to be 2. So we know that h, or the x-coordinate of our vertex, is going to be 2. And we still need to find k, so let's take it and let's plug in our function. Here, let's do plug in 2. So we've got 2 plus 2 times 2 minus 6. I just plugged it right into the original equation. So we have the function of 2 is going to equal 4 times negative 4, which in this case here, again, is going to end up giving us negative 16 again. Now they're not always negative 16. This is just, they happen to be in this case here. So k equals negative 16. And our next part of this then is we're going to take it and actually, if you want to check it, go ahead and graph it. We'll do that real quick here. We want to get in the habit of doing that. So we have x plus 2, and we have x minus 6. Graph it. And you'll see our lowest point down here is where x equals 2. That's a good sign there. And if we want to look at our table, we have 2, negative 16. So we know we're on the right track here. So we're going to take it. A is 1 right now, so we're going to just write it in our vertex or graphing form. So y is equal to the quantity of x minus 2 squared minus 16. There is our second one. Vertex, remember, is 2, negative 16. Moving on to C. I don't want this one to get too long, so I got to pick up the pace a little bit. We have y equals x squared minus 14x plus 40. This one's different because now we are in standard form to start out. So when I'm in standard form here, what I want to try to do is I want to get it to factored form. So let's factor it. And when you factor it, you should end up with x minus 4 and x minus 10. If you needed to go back and take a second to factor it, that's fine. Go ahead and do that there. I know I'm pretty good at factoring. I've been doing it for many years. So if you need to take the time to pause it, make sure you understand where that came from, go ahead and do that. Let's take it now. Use your zero product property. Actually, we'll set it equal to 0 first. So get our x-intercepts, then use our zero product property. So x minus 4 has to equal 0. Our x minus 10 has to equal 0. So x is going to equal 4. Or x equals 10. Now that one's a little bit easier to take and come up with our average, our middle there. If you think about what's halfway from 4 to 10, it should be 7, but we can still take and do the average. H is going to equal 4 plus 10 divided by 2. This will give us the point that's halfway between them. 14 over 2, 14 divided by 2 is 7. And now let's take our 4 and let's plug it in. I'm sorry, our 7 and plug it in there. So f of 7 equals 7 squared minus 14 times 7 plus 40. Now we could do that one. You could also do this one. It's probably going to be easier. Probably would have been a smarter move on my part to do that, but let's see what happens here. We should get the same answer. 49. 7 times 14 should be 98 plus 40. So I have 49 and 40 gives me 89. 89 minus 98 should give me, I believe, negative 9. I hope I'm right because I've been working for a while here. So let's see here. Let's graph this one real quick. See if we get the same thing. X squared minus 14x plus 40. And it looks like we're at 1, 2, 3, 4, 5, 6, 7. And then we're going down 9. Looks good. Let's just look at our table. And you see we're at 7, negative 9 is the vertex point there, so that's good. So our next step here is just going to be to take it. We've got our vertex is at 7, negative 9. So H is 7. K is negative 9. Let's put it into our vertex form. Y equals x minus 7. That's not a 7, is it? What am I doing? X minus h, our h is 7, squared minus 9. All right, we're almost through with these ones here. Let's get into the last one. Y equals the quantity of x minus 2 squared minus 1. Now when you look at this one here right off the bat, you know that this is already in vertex form. That's a good thing because that's what we're trying to get it to already. So when we look at our vertex, it should be our point HK. Remember, H is going to be, when you look inside of here, H is the value that's being subtracted from X. So H is going to equal 2, K equals -1, which means our vertex is going to be the point 2, -1. And that's it. This is letter D here. It's already in vertex form, so all we needed was to find the vertex. This is problem 2-36 from the homework. If you have questions, please make sure you ask your teacher. Otherwise, thanks for watching. Hope this helped.